binomial. Binomial distribution. Binomial distribution. Now, if you have an event whereby you have a number of successes, in n independent trials, with the probability of success p and the probability of failure 1 minus p, then that kind of event follows a binomial distribution. You try severally, others you get success, others you get failure, but now you are interested in the number of success. You are interested in the number of success after n independent trials. And this is a distribution. This kind of event follows what is called a binomial distribution. Of course, we have to write the PMF. The probability mass function is given by n combination x plus p. X is equal to x is given by n combination x, p of x 1 minus p, n minus x. You are interested in the event success. The event x is the event of success. But you try n times. So n looks like the sample size. You try n times with the probability of p success and the probability 1 minus p of failure. So this one is the probability mass function for a binomial distribution. There's a relationship. When you don't remove, if you remove this one is Bernoulli alone. This one alone, right? Of course, in Bernoulli there is no n because you only try once. So here will be 1, right? In Bernoulli it will be 1. So this one, there is a relationship between Bernoulli and binomial. So if you sum Bernoulli trials, then you get a binomial distribution. And we will use that one to find the expectation and the variance of a binomial distribution. So the expectation of x, because x is a Bernoulli distribution with n independent trials and p success, but there is a relationship between Bernoulli between binomial and Bernoulli. So it means x is the sum from I is equal to 1 up to n. The ij, where ij is the indicator variable for Bernoulli distribution. Right? So if we get the expectation of x, oh no, this is not e but x. The expectation of x will be the expectation of summation from I is equal to 1 up to n, the ij's. So this is now the expectation of course, summation from I is equal to 1 up to n. Expectation, you bring in the expectation inside. One of the properties of expectation is this one we have calculated from Binomial. So this is from I is equal to 1 up to n. So this one you get n, this one alone. You are summing n events, you get n. But this one you get p. We have got this one from Binomial. the expectation of a Bernoulli distribution is P. So for binomial, you get NP. You get NP. Variance of x is the same as the variance of what? The variance of summation of I equal 1 up to n, the I is n. So this one is now summation from I is equal to 1 up to n, variance of I j. So this one is now n from here. Then here we get it p into 1 minus p. So that is np into 1 minus p. So that is the expectation and the variance of a binomial distribution and the probability mass function. Up to this point, we will only talk about these three: the PMF, the expectation, and the variance. The first and the second components. The next, as a binomial distribution with n is equal to 100 trials and probability of 0.5. It's like tossing a coin, 100 times, and probability of success is a half. What is the expectation of x? Expectation of x you have got to be np. So that one will be 100 dot 0.5. Which is equal to value of x is same as np into 1 minus pm. So np is 50. 50 into 1 minus p. 0.5. So that is 25. Right. And now standard deviation will be the square root of 25. It is equal to 5. So you see, quite easily done for this kind of distribution. A certain lizard lays eggs. A certain lizard lays 8 eggs, which will hatch independently with a probability of 0.7. A certain lizard lays 8 eggs, each will hatch independently with a probability of 0.7. Now you are asked to tabulate and plot the probability mass function. Tabulate and plot the probability mass function of the number of eggs which hatch. So an egg can either hatch or it will not hatch. So that is the Bernoulli. But there are 8 eggs. This lizard or this hen, if it was a hen, has laid 8 eggs. So it is no longer Bernoulli but now binomial. So if the number of x, you let the number of x that will hatch to be y, then it means it implies that y is follows a binomial distribution with 8 and probability of success 0.7. So from here we can get the PMF, the probability mass function. Probability mass function PMF is given by P y is equal to x here will be n combination x p raised to power x 1 minus p n minus x. But what are the events? There are eight. There are eight events here. There are eight possible outcomes. Huh? We have a situation whereby no egg is hatching. This is x. One egg is hatching. 2x, 3x, 4x, 5x, 6x, 7 and 8. So the probability P y is equal to x. Now, what we do here, we use the PMF to generate the probabilities. We use the PMF to generate the probabilities. So, for x is equal to 0, we have 8 combination 0, p raised to, the probability 0, but success is 0.7. Will be raised to power 0, and failure is 0.3 raised to power n minus 8 minus 0 is 8. You get that? The next one, you have 8 combination 1, 0.7 raised to power 1 now, 0.3 raised to power 7. One egg hatching, the probability of one egg hatching will be, you can use calculators to solve this. Then we have 8 combination 2, then 0.7 raised to power 2, 0.3 raised to power 7, raised to power 6, and you go until you reach 8 combination 8, 0.7 raised to power 8, 0.3 raised to power 0, which is that for 6. And then that one you will have obtained the probability mass function for this distribution. Then for the CDFs, you add them cumulatively. You add them cumulatively. Yes. Thank you for watching. That is our video.